Google TurboQuant and Cerebras are solving the same problem: how to run large AI models faster and cheaper. But they approach it in completely different ways. One is a software optimization, the other is a radical hardware redesign. Starting with Google TurboQuant, it's not a chip. It is a technique that reduces how much memory an AI model needs to run. AI models store billions of parameters, and each one takes space. The more memory required, the more expensive and slower the system becomes. TurboQuant compresses these parameters so they take up far less space while trying to keep the model's accuracy intact. The key idea is selective precision. Instead of treating every part of the model the same, TurboQuant keeps higher precision where it matters and reduces it where it doesn't. This allows memory usage to drop significantly. Reports suggest up to around 6 times, without breaking performance. This matters because most AI bottlenecks today are not just about compute power, but memory. GPUs and TPUs often spend time waiting for data to move in and out of memory. By shrinking the model itself, TurboQuant reduces that bottleneck. The result is lower cost, faster inference, and the ability to run larger models on the same hardware. Now compare that with Cerebras. Cerebras systems took the opposite approach. Instead of optimizing the model, they redesigned the chip entirely. Their flagship processor, the wafer-scale engine, is not a normal chip. It is essentially an entire silicon wafer turned into a single processor. This chip is enormous compared to traditional GPUs. It contains hundreds of thousands of cores and trillions of transistors on a single piece of silicon. Because everything is on one chip, it avoids one of the biggest problems in AI systems: communication between multiple chips. In traditional setups, you need thousands of GPUs connected together. Data constantly moves between them, which creates delays and inefficiency. Cerebras eliminates most of that by keeping everything on one massive chip. This leads to very high memory bandwidth and lower latency. In some cases, Cerebras claims its systems can outperform large GPU clusters and even run certain AI workloads many times faster while using less power. So, in very simple terms, Google TurboQuant is about doing more with less memory on existing hardware. Cerebras is about building entirely new hardware to remove the bottleneck completely. There is also a difference in how they are used. TurboQuant works with existing infrastructure. Companies using GPUs or TPUs can apply it without changing their hardware. That makes it easier to adopt, especially for cloud providers and developers who already have systems in place. Cerebras, on the other hand, requires a completely different setup. You are not just buying a chip. You are buying a full system built around that architecture. It is powerful, but it is also less flexible and harder to integrate into standard environments. Another key difference is scalability. TurboQuant helps scale by reducing the cost per model. You can run more models on the same hardware or deploy them in smaller environments. Cerebras scales by increasing raw compute power. It is designed for extremely large models, including multi-trillion parameter systems, where traditional GPU clusters become inefficient. Both are trying to solve the same underlying issue. AI is becoming too expensive and resource-heavy. One reduces the problem. The other tries to remove it entirely. Which approach wins depends on the use case. If the goal is to reduce cost and run models efficiently on existing systems, TurboQuant is more practical. If the goal is maximum performance for extremely large models, Cerebras offers a completely different level of scale. In the long run, both approaches may end up working together. Efficient software like TurboQuant can reduce demand, while powerful hardware like Cerebras can push the limits of what AI systems are capable of.